She is also pa- she is also passionate academician and was former full professor with Nirma University. She is also involved in AI-based skilling of more than 2,000 professionals through various initiatives at national and international level. She was worked as principal investigator on multiple projects funded under Shastra Indo Canadian Research Grant, DAE, Vishwavarya PhD scheme, IPR, etc. Ma'am is currently guiding 7 PhD students in the domain of AI and has published more than 48 research papers in international journals, books, and references. Dr. Sharma has international exposure includes visits to San Jose, Los Angeles, San Francisco, Long Beach, Toronto in Canada, Dubai, and Abu Dhabi for various industrial collaborations and research-based associations. So I welcome you, ma'am, in this third session of online AI FGP program.
Yeah, thank you very much. Thank you, Dr. Dipti. And thank you, all the
So,
participants. Am I audible properly?
yes, yes, ma'am, you are very much audible. I think without wasting time, now it's over to ma'am.
Yeah, sure.
Ma'am, yeah, ma'am,
Yeah, yeah.
please kindly start with the session. Yeah,
Yeah, yeah.
thank you, ma'am.
So thank you so much. I hope we have an interesting session today, and I must congratulate the organizers, Yashwant Singh sir and Dr. Deepti, for organizing such an interesting program, and I'll say apt program where we are talking about mental health and other issues like that, and how AI can help us in in solving some of the unsolved issues, or maybe to provide support system for people who are working in this area or who are facing health issues in this particular area. So, and also last few years has seen a phenomenal amount of development and the applications of AI as far as healthcare and pharma sector is concerned, right? So today I would like to take this opportunity and divide my session into two parts, right? The first part is going to be discussions about how AI and deep learning can be used for healthcare sector. So we'll also touch some of the fundamental concepts related to deep learning, and because that's important to understand how this kind of applications are built. So we want to basically see at ground level, we want to see from applied perspective, and we want to develop a capacity of developing systems that can be used as a decision support system, or maybe some kind of healthcare support to people who are facing neurological issues, or any kind of deterioration in mental health because of ongoing problems that they have, right? So first half of the lecture will basically be it will be mostly related to catching up a scope identification of our discussion, and also also talking about some of the fundamentals in this area. And then second half I will be discussing about a decision support system that we have basically developed in collaboration with Sign Hospital Mumbai, and that is one of the ongoing work of my PhD student as well, right? So I hope my screen is visible to everybody.
Yes, sir. Yes, ma'am, it is very much visible.
Okay,
Yes,
thank
ma'am.
you. So let me just put my video off, because now we are going to be dedicated to the presentation, right? And whenever required, we can have a discussions. You can interrupt me, like you can unmute yourself and speak and ask if you have any questions, because while I am displaying my screen, I may not look at the chat window, right? Or we can have question answers towards the end of the session as well. Okay, so this just talks of my affiliation with companies like Deepti has already mentioned that we are into ERP system development of healthcare and pharma sector, and I'm also associated with Orbit Pharma, which is a UK-based company. There also we are dealing in terms of developing healthcare and pharma related products. right? So I will try to justify my presence in this particular workshop, and I will try to give you as much information as possible to give you a kickstart in going ahead with application development or doing some AI based research work in this area. Right. So the base topic of our discussion today is going to be remote patient monitoring, which we also term as RPM. And RPM basically uses digital technologies to collect healthcare related data from individuals, right? And so the basic fundamental of RPM is to provide seamless access to healthcare, right? So seamless essentially means that for example, you have a system that is reading your heartbeat. So at the same time, the system is able to read your other vitals as well, right? And it's like a continuous system in which variety of data is being read by your healthcare system, and accordingly the analytics related to that is also being read, right? So that's the meaning of seamless access. Then comes improved quality of care and support. So obviously remote patient monitoring, that COVID has taught us a lot, right? And there were in the initial phases, that means when first wave came, there were so many people living in complete isolation whenever they were infected, right? And eventually people had confidence, and maybe in the second waves you were able to hold them in your house, or you knew how to protect yourself, right? But in the first phase, there were a lot of people living in complete isolation, and then with the kind of turbulence that it created within your body, sometimes it used to lead to some lapse of attention and death of the individual as well, right? So obviously if we are able to provide a good remote patient monitoring system, it will provide a good quality of care and support. Then comes peace of mind and daily assurance. I think this does not require any discussions, right? So obviously you can, I will be coming to complications of Parkinson's disease, because Parkinson is like mother of all diseases. Like once somebody is infected with that disease, gradually the body almost starts disintegrating different parts of the body, and the person suffers from variety of other diseases just because of Parkinson. So remote patient monitoring can provide a lot of peace of mind to people who are trying to support their close relatives who are affected with Parkinson, right? Because at the end of the day, everybody has to work. So when you are leaving your parents or your relative who is suffering from Parkinson's at home, you would like to have a system by which there can be a remote monitoring of the person who is based at home, right? So daily assurance, and then obviously continual feedback. So you look forward to developing such systems so that you can have a continual feedback on the status of the health of the patient, right? So this picture basically shows how the healthcare or remote patient monitoring has evolved over a period of time. So this is healthcare 4.0, healthcare 5.0. So healthcare 1.0 was in 1970 to 1990, where the focus was on physician centric treatment. And then eventually we had 2016 to 19, basically healthcare 4.0 brought out a lot of personalization issues. And personalization issues means person specific healthcare, which basically required real time collection of data, and then using AI for collaboration and coherence, and using a lot of multimedia data for analytic purpose. And thereafter, from 2020 onwards, healthcare 5.0 the focus was more on a lifelong partnership, or there was a customer centric model, or high quality care, highly responsive system with good feedback mechanisms, right? So these are some of the key factors of healthcare, of the evolution of healthcare services worldwide, right? And this also shows the need for remote patient monitoring that has grown over a period of time. This is this picture basically is related to this is related to how machine learning models can be used for development of remote patient monitoring systems. So as you can you can see over here, so you have different variety of input generators, like you have radiologist. So radiologist who is able to interpret MRI and such kind of scans from radiology based systems, or you have patients indoor outdoor, they are generating data. So this the left hand side, or at least the leaf nodes in this picture, they are basically representing different kinds of data generation. And then there is something called decentralized AI. So you can keep this picture in mind, but I hope I know that none of us are alien to the concept of how model training basically takes place in AI, right? So you have your input data, which is basically having features based on which your learning model has to develop, and then you are dividing that into training data set, testing data set. Then training data set is used to train your model, and whatever is the outcome that you are using for applying early detection or doing some kind of prediction, and based on that you are testing the system, and you are doing analysis on the model that you have developed, right? So the diagram is cluttered because we it is basically trying to show different kinds of possibilities of working with of using artificial intelligence or machine learning models for development of remote patient monitoring systems. But typically the takeaway from this picture is that we can use machine learning for developing different kinds of diagnostic systems, different kinds of feedback predictive systems, right? So prediction of a problem, different kinds of real-time analytics, right? So that's also something which is possible. Okay. Then if you just see the taxonomy of a remote patient monitoring system, then they can be categorized into systems that are where AI is being used for healthcare monitoring, or system where there can be a blockchain based patient monitoring, or system where you can use wearable sensor based survey, or system where you can use IoT based remote patient monitoring, right? So people who are interested in working on remote patient monitoring can either use AI for developing a healthcare monitoring system, or they can use blockchains, like they can work in the area of developing a blockchain based model for sharing of healthcare records, or they can work towards developing wearable sensors which can be attached to patients in general, and then that can be used to capture the right amount of data, or they can be focused at developing a IoT based real-time patient monitoring system. So basically there are different areas in which you can go and you can focus your work on, right? So I'm just trying to give different avenues of going and contributing to the area of remote patient monitoring. And you can see there can be a mobile application based diagnostic system also, right, where you develop the system. I remember during the COVID days, I think some prominent university of US, they developed I think Stanford University to start with, they developed a mobile app where you can just upload the chest x-ray of the person, and it tells whether it is infected with COVID or not, right? Because initially there was a lot of diagnostic issues where the model that people were using to identify COVID, that that used to get confused with the deterioration in chest because of pneumonia and because of COVID, right? So because to a large extent it looked similar, right, in the initial days. So the AI models, which was basically used to identify COVID, used to be biased with pneumonia, and in majority of the cases it used to detect the symptom as pneumonia only, right? So they basically developed a reliable mobile application where the chest x-ray could be uploaded, and it used to give a proper diagnostic of the percentage by which you can say that the chest is affected with COVID or any other disease, right? So you can develop a mobile app related system as well. Then IoT based real time patient monitoring system. I here just before we move on to the rest of the discussions, I this just reminded me of one project query that I had some time back. There was a company, they wanted us to develop a system, although we didn't go for that system. I will tell you the reason why, but they wanted us to develop a system that was for monitoring, remote monitoring of what are they known as? Of the human trial, right? It's known as human trial. So human trial essentially means whenever a new vaccine or medicine is created, before actually making it public, there is a process by which it is tried on human beings. And you know that there is a risk involved in all these mechanisms, right? Because when somebody goes for human trial, then they need to give a declaration that if anything happens to them, then the organization is not to be blamed, and in return of that they get some monetary compensation, right? So because of the monetary compensation, what happens is in the economically backward areas, they have started making this as a business, you won't believe. And people are basically sending women of their families to go and work for this human trial. And what happens during this mechanism is that they are administered with the drugs, and I think for around 3 days they need to stay in the campus of that human trial center, and the person is monitored for changes in the health. And depending upon the type of medicine that has been administered, the trial will be continuous, or it will be like once in a while. So it may be a proactive kind of remote patient monitoring, or it can be reactive. Proactive means when there is a constant feed of data, and reactive means only when your system predicts there might be a problem, the diagnostic will start, right? So that's your reactive and proactive system, right? So now they wanted to develop this system for us. So now of course there were many issues related to that, because there are lots of ethical issues related with human trial, because I told you that there is a misuse of this kind of mechanism also for money, right? And they actually, they, apart from remote patient monitoring, they wanted us to develop a system by which we can identify that the person who has come for human trial does not come again within a period of 3 months, right? Why it is done like that is because there is a rule, right? It's a medical rule that if you have been administered with a new drug, then you cannot be given another drug for next 3 months, because that's the period of monitoring the changes in the body, maximum period. Mostly it's 3 months. So it is said that within a period of 3 months the same person cannot be given another drug. But just because they get money for this, what they do is they change their looks, right? They will change their features, they will change their looks, and they will go to some other center with a mistaken identity. They will try and show some other forged documents, and again will go for the process of human trial, of course. And in this process what happens is a lot of people die also, right? Just and so this company wanted us to develop a system that can work towards identifying people who had previously come to any one of the centers, right? So this was basically a face detection system, but face detection system where the intention of the person was to change their look. So they used to, maybe they'll just add a mustache, or women will use some other mechanisms, men will use some other, there are different ways. You already know people try to play with their identity. So basically coming up with a face detection system or person identification system where it is able to take care of all these aspects. Okay. So this was this was a case where they wanted a remote patient monitoring system, and they also wanted a system by which we can do personal identification, right? And so I'm just giving you examples of remote patient monitoring. One could be that it is for Parkinson's patient. Why it is for Parkinson's patient, that we will discuss in the second half of the session. And the second is for this kind of human trial thing that we have seen. The third case study could be remote patient monitoring for cancer patients, right? Because yeah, I don't know, maybe you might be knowing that majority of the cancer patients, they die because of complications of chemo treatment. Because what happens is, in the chemo treatment there are multiple changes that takes place in the body. And there are so many people who would basically die because because their what is that, the blood pressure either falls down, or there will be a fluctuation in the pulse, or the WBC count goes low, or the immunity is affected, many other issues related to chemo treatment. So most of the time it is said that people don't die of cancer, but they rather die because of the complications of chemo treatment. And it is believed that the complications related to chemo treatments is manageable, right? But still so many people die, right? Sodium level went down, so there has to be a system where and the health of these people fluctuate a lot after chemo. After at least 1 week or 2 weeks of chemo, it fluctuates a lot. So a remote patient monitoring can also help people who are suffering with cancer, and especially just after their chemo treatment, when they need to be kept on watch. And you don't always have the flexibility of leaving them in hospital. It is not just a affordability problem, because it's going to be very costly, but it's also a problem related to infections, because hospital is also the hub of lot of infections. So after chemo, when their immunity goes down, sometimes doctors will say, you if it is manageable, take them home, because hospital is also a place where they will be prone to lot of infections, and that is why they say this will rather create a complication, so you can take them home, right? So again, you need remote patient monitoring for cancer patients. And Likewise, lot of things. This also reminded me of another interesting this thing. Interesting example where one of my friend in US, no, he went through a very what is that a very big surgery, and that surgery was related to okay, let me not discuss complication of that surgery, but he went through a very major surgery in US, and he was almost immobile for a very long time. So just after the surgery, we typically call and ask our friends, "How are you?" This and that. So I just called him. I said, "How is everything? How did your surgery go?" This and that. So he said, "It's all well." I said, "Who is there to take care of you?" So can you guess his answer? His answer was only buttons. Buttons, right? So I said, "What do you mean by buttons?" So he said, "Priyanka, in US we have only buttons to take care of us." And he was not of course he was an American, but of Indian origin. So that means um, the culture there evolves like that, you know. And the hospitals basically have developed a ecosystem where they are not expecting people or at least relatives to be a backup support in hospital rooms, right? Rather what happens is they have systems in place, and what they do is they tell people that if you have any problem, if you have this problem, you press this button and call the nursing staff. If you have this problem, you press this button. If you have this problem, you press this button. So eventually, you know, their entire caretaking is managed using buttons, and there is no human intervention in all this thing. So I had spoken to him around 4 5 years back when he went through this surgery, but that is when I realized that they already have such an advanced remote patient monitoring. And it was not a simple surgery that he went through, it was a very major surgery, right? And for which he went through 21 different surgeries to reach to that level. So you can imagine, it was such a complicated surgery. And in spite of that, when I asked him, "Who is there to take care of you?" he said, "Only buttons." Right? So that means these countries are already advanced when it comes to provide healthcare support remotely, right? So I believe that in India, you know, it is and RPMs are gaining momentum because you know, they are also considered to be affordable services. At least they are cheaper than paying hospital bills. Wherever it's possible to keep people at home, they are cheaper than hospital bills. So that's why they are considered to be a kind of affordable solutions as well, right? So so it's important that we are discussing about these systems, and it will equally be important if you are able to work on projects to develop remote patient monitoring systems that can be used for monitoring healthcare of different kind of people. And the other interesting thing that we should quote over here is that these days, irrespective of what problem people have, they will suffer from depression, right? Whether the person is suffering from cancer, the person is suffering from some neurological degeneration, the person is suffering from COVID, they will get stressed and feel depressive, right? So that's the state of mental health. So that's why it becomes very very important that, you know, we drive our effort towards research and product development in this. I always talk in terms of product development, develop project, come up with something in this area, right? So it becomes very important that we evolve ourselves and we try and contribute to developing some kind of systems which can be used to handle this kind of problem. Okay, now let us try to touch some of the fundamental concepts related to deep learning. I understand that some of you might be knowing, but we are just trying to sync up, so that everybody is at same level when it comes to understanding or using concepts of deep learning. So even when you feel that this is something which I know, but I will still recommend that you listen to the discussions, and you can mentally try to apply, okay, ma'am is telling this is where I can use this particular concept, right? So that's how we can go ahead. Now, so in this particular picture, we have three terms, which is artificial intelligence, machine learning, and deep learning. Now, just to tell you, artificial intelligence is a bigger umbrella, and deep learning is just a block which is within this AI, right? So, so you can see that deep learning. So AI existed right from 1948, but then AI became popular the way it is with the evolution of deep learning. And deep learning basically became, actually, if you see the first model of deep learning, that was LayNet, right? And if you read research papers, you see that the first model of LayNet came up in 1994, right? And then the LayNet 5, fifth version of LayNet, came in 1998, right? But still, you see the deep learning block after 2000, it's actually 2012, slightly after 2010, so 2012. And this was because of a deep learning based model, which was AlexNet. And this was award winning model in the ImageNet data challenge. So this particular model in the ImageNet data challenge basically made deep learning popular. Why? Because it was seen as a computational algorithm which surpassed human intelligence, right? So we have to basically understand that this is an era, right, where artificial intelligence is not expected to be artificial, it is rather expected to be human like, right? That's what you have to keep in your mind, that we have now entered an era where artificial intelligence is not expected to be artificial. Now you understand, of course it's artificial, but it's not expected to be artificial, it is expected to be human like. And it's because of this expectation that deep learning has been accepted in every domain of science and technology, right? So it's everywhere, it's pervasive now, right? And also the three factors that led to the growth of deep learning was deep neural network, then GPU, and big data. Deep neural network is basically the advanced algorithm that was developed as one of the contributor to the advancement in machine learning. GPU basically stands for graphics processing unit, or the hardware support which is required to work on deep neural networks. And big data is basically the large volume of data that you need to work with when you are developing these algorithms. So it was growth in big data as well as availability, because if you don't have good GPU resources, you will not be able to work with deep learning models, right? So it was that's why we say that the big bang in machine learning was basically brought up by advancements in deep neural network and graphics processing unit, which is the hardware support and availability of large volumes of structured as well as unstructured data. Okay, so this is known as the three contributors to the big bang in machine learning. And what is AI doing? AI has basically revolutionized, and it has become pervasive with multiple domains of science and technology. That I said, it's being used in oil and natural gas, it's being used for smart city initiatives, it is used in retail for increasing sales of a particular company. In healthcare, that's our major focus of discussion for this particular FDP. In biopharma, so for drug discovery, for developing automated temperature control systems or temperature monitoring systems of the body, or these days, oximeter has become so popular, maintaining your your oxygen level and pulse. So that device we hardly heard of a few years from now, right? But that's pharma IT related product. That's also a pharma product. So pharma is not just medicine, right? Pharma means again using IT for some kind of healthcare support. Then industrial automation, so like robotics, real time inspection of industries and things like that. Financial, so fintech solutions, which company should you invest your money in, so that's your financial fintech solutions, right? Or identifying what is the growth pattern of a particular company, or identifying that if these are the attributes of a company, what is its growth probability after 2 years, or growth probability after 5 years. So identifying the net progression score, it is known as NPS. So identifying the net progression score of a particular company as a measure of their improvement over a period of time, that's called that's like using AI for fintech solutions. And then automotive, I think everybody knows about this, making self-driving cars, Tesla cars, right? So that's your automotive car. Then various applications where AI is being used. So image and video classification, speech recognition, NLP. I think most of these areas you might have heard of. Cancer cell detection, grading, progression detection of diabetics based on eye scans, right? So that's called diabetic retinopathy. So identifying deterioration in eyes because of diabetes. Real-time translation, cyber security, pedestrian detection, so on and so forth. So these are areas where it is being used. This is expansive universe of modern AI. So we see that large number of companies are investing for AI research. Then these are companies working towards development of core technology related to AI, developing frameworks that we are using, like CUDNN or Cafe TensorFlow. These are AI frameworks. So companies who are working towards developing frameworks related to AI, companies who are working towards providing AI as a platform. So if you buy Amazon Web Services P3 instance, so P3 instance gives you access to GPUs through Amazon AWS, right? So that's like using AI as a platform. And then you have lots of startups who are coming up and contributing to development of AI based applications. And then there are industry leaders in terms of using AI for product development, right? So this is expanding universe of AI. Now I will, just a second, let me just play this interesting video for all of you, and then we'll continue with the rest of the slides. Just a second. You can let me know if the audio of the video is not audible. I am AI. Can you listen to the audio?
Yes, ma'am, it
Yes,
is very much
madam.
audible.
Yes.
Okay. I am AI. Accelerating your discoveries to solve the great challenges of our time. I am a visionary, bringing characters to life with more natural movement, generating brilliant new worlds for them to explore, and inventing new ways to bring out the creative genius in us all. I am a protector, leading the way into the most dangerous environments and searching for signs of life.
I am a guardian, listening for the sounds of destruction to save our forests, and using satellites to bring freedom to those who are enslaved. I am a navigator, finding safer paths for cross-country deliveries and taking personal travel to new heights. I am a scientist, exploring oceans of data to understand extreme weather patterns and studying the building blocks of life to save a community from hunger. I am a healer, giving hope to those who suffer from the most challenging diseases. And tapping into the brain to rejuvenate paralyzed limbs. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, so this video I just wanted to play so that we have an idea of what all domains AI is already being used for, right? Because whenever we talk about using AI for healthcare, we have to basically work with variety of models as one. That means you can't just be focused on, let's say, object detection or segmentation or anything of that sort, right? Your model cannot be isolated to one facility. You need to work with multiple things, right? So that's why we need to have a overall picture of what is the strength of AI, so that we don't develop an algorithm and fit in that to a problem, but rather we identify a problem and then we identify group of algorithms to solve that particular problem, right? So your approach should be this way. So these are different kinds of machine learning algorithm. We all know what is supervised, unsupervised reinforcement, but you can just look at the applications that it basically caters, different kinds of machine learning algorithms. So it's being used for estimating life expectancy. I will just touch some of the healthcare related examples. Estimating life expectancy. So I'll just give you an example. I was attending a conference. It was an NVIDIA conference in US in 2013, and you won't believe that out of that GTC 2019 is the conference I'm talking about. That conference was attended by 9,000 people from all over the world. It is known as the number one AI conference. And this particular conference had lots of speakers. There were lots of parallel tracks. It was a 5-day conference, and you won't believe there were 40% speakers of this conference were doctors, not like me and you, but medical doctors, right? 40% speakers were medical doctors, some radiologists, some heart specialists, some pediatrician, and some gynec surgeon, and they were all talking about using AI for improving the quality of medical support that they are able to provide, right? And they were using languages like convolution, pooling, using filtering, this kind of. So they were talking, we took data from this hospital, then we applied this kind of convolutional network. So doctors basically using AI for providing better healthcare practices. And somehow I found that this particular acceptance of AI in medical fraternity is lacking in our own country. So we should also, try and collaborate with medical doctors and come up with project scopes, where we can work together in providing better healthcare services. And I remember one interesting problem related to estimating life expectancy, which I had attended in that conference. So there was a heart specialist. He did some research related to arrhythmia heart rate. Arrhythmia heart rate is I don't know if you have heard about this. Arrhythmic heart, that heart rate is a periodic thing, no? Dhak, 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 dhak. So it's a periodic pattern. Arrhythmic essentially means that rhythm is not there. So sometimes it may be very fast, sometimes it may be slow, right? And so that's basically arrhythmia. And various factors can lead to arrhythmic heart rate, which could be like stress, or it could be driven by some medicine which you are using, or it could be in fact COVID also created a lot of arrhythmic heart rate patterns in some people. And that some people died of sudden cardiac arrest in COVID. So we heard lots of cases where the person who had healed had come home and then everything was normal and suddenly there was a heart attack. Of course, the reason to that was a sudden clotting problem, which was created because of COVID. But many people, they suffered with this arrhythmic heart rate or fluctuation in pulse rate because of the disease. So pulse fluctuation was also one of the problems that people came across in COVID. So there was a doctor in this conference. He presented a research where he studied the arrhythmic heart rate of people who were going through some heart issues, right? Heart diseases. And then suppose if the family calls up the doctor that my family member is suffering like this and that, so there will be a some you will get access to a facility. Suppose you are staying in a remote place, still you can have access to the device with which measures your ECG device, and that image goes to the doctor has an analytic system based on which he is able to make a prediction on the life expectancy of that particular person, because he is suffering with arrhythmia heart rate, right? So he said that in many cases we were able to make some 95% accuracy that this person is not going to live anymore, so that the family can save on the amount of rushing that person to hospital. Suppose somebody is staying in a remote area, so rushing that person to hospital, ending up spending a lot of money, and you just come and get to know that the person did not survive, right? So I know it's not a easy decision to take, but in Western world people are practical, they called it a practical way of thinking, which so in this practical way of thinking, they are able they are now working on measuring on working towards estimated life expectancy of people and accordingly deciding line of treatment. Same thing can be done for cancer patients as well. So sometimes doctor says that there is no point spending money on this person, because whatever you do, this cancer, it cannot be healed, or the stage at which this person is cannot be healed. But and then we have to take a decision on what is the modality of treatment. Sometimes it is not like deciding, okay, we'll let this person die, because that's again not the right thing to do. But sometimes life expectancy can be used to identify the modality of treatment. Like I had come across a person where his grandmother was detected with, I think, esophageal cancer, throat cancer, uh, and she was 84-year-old. So she could not take the stress, although she had a good health, she could not take the stress of chemo and radiotherapy. So they said, we did some test and we are now going for immunotherapy. And using immunotherapy, she her life at least extended for I think around close to 2 years, which initially the doctor said that she cannot carry on more than 2 months, something like that. So life prediction of life expectancy can be used also to decide the line of treatment. That is what I'm trying to say. I don't want to stress upon, because I also don't believe in that first theory where we talk about being practical. It's not possible to become so practical for us, right? Uh, but then at least if we can develop system that can help the doctors to identify line of treatment, based on the prediction of life expectancy of a particular person, that then that person can go in peace, right? Sometimes that's also a compromise that you have to make with life, that at least that person goes in peace. And when it comes to dealing with Parkinson's disease, because that's going to be our major focus today, or any kinds of neurogenerative disease means when there is a deterioration in the neurological function of the body, or it's basically a brain degeneration. So any disease that's related to degeneration of brain affects the whole body. So life expectancy can also be used for diseases like progressive supranuclear palsy, which is a kind of neurodegenerative disease where deterioration is very fast, and it helps the family as well as the neurologist or other support doctors of the patient to decide that, okay, what should be our line of treatment so that this person can go in peace, right? So these are dark areas, right? They make you sad when you listen about them. But that's the challenge of working in healthcare sector, or that's the challenge of working towards diseases which are neurogenerative in nature, right? And that's the challenge we have in learning how we can use AI to give better quality of life, whatever life they have, but better quality of life to those people, right? So that's the basic intention. So this is just a workflow which shows basic difference between machine learning and deep learning. So this is just for you that in machine learning we are dependent upon handcrafted features, where features or data with features are fed to the system, and in deep learning your mathematical model or the deep neural network is basically able to extract the features automatically. So this is a self driven model and this is a human controlled model. So the accuracy of this model will depend upon the intelligence of the humans, but in this case the accuracy will depend of course upon intelligence of humans only here also, because basically you are the one who is going to design the network. But then the human intervention here is still very less, and most of the features which are used to identify or distinctly identify the images is being controlled by the system. Okay, so typically your AI and deep learning is used to handle these 5 categories of problem. One is if we align everything with reference to cancer, so detection, which is the cancer present or not; classification, which is like what type of cancer it is, so tumor identification; segmentation means what's the size of the tumor and what's the shape analysis, so that's called segmentation. Prediction is we have already discussed, like life expectancy is a prediction problem, survivability prediction, right? And recommendation means therapy recommendation, like for example, if the deterioration level or the progression of cancer is to this extent, then what is the kind of therapy, like this immunotherapy example which I gave you, that somebody decided to go for immunotherapy instead of chemo and radiotherapy because of the status of the health of the patient, right? So that's called therapy recommendation. So these are the 5 categories. Object detection model, which identifies cats, chairs, dustbin, anything in a particular image, right? Segmentation is when you are able to extract a portion of this particular person or of some entity in an image, right? Then this is, somebody has unmuted. Please mute your mic. Somebody has unmuted. Mahmood Ali. Please mute your mic. Yes, thank you. So this is example of pose estimation. So pose estimation can, if you talk with reference to Parkinson's problem, then the one of the initial ways of identifying Parkinson is gait movement. So gait, you know what is gait? Gait essentially means the distance between your knees when you are walking, right? And what is the pattern by which the distance between your two knees are changing? Okay, so you can see whether you are ill or you are not ill will depend upon how you walk. ऐसा बोलते हैं कि चाल से लग रहा है कि इसकी तबीयत ठीक नहीं है. So this gait movement is again considered to be one of the human signatures. Do you know that? Gait movement is considered to be one of the human signatures, just like your retinal scan or your this finger scan. So likewise, gait movements is being identified as one of the what do you say, one of the ways of distinctly going and identifying a person, right? So gait movements can also be used to identify the deterioration in the progression of Parkinson patient, because in it's the first thing that it affects is the way they walk, right? And that is basically identified by this, the on the top whatever you are seeing, pose estimation. So pose estimation can also be used to identify a particular human action. For example, he is sitting on a boat or he's just lying down like this and he has this movement. So different kinds of motion, right? So whatever action this person is doing can be identified by pose estimation. And I think you can well figure out that pose estimation will look at the size of your or movement in your limbs, right? Basic structure of your body. It is not focused on your face detection or emotion detection will be a different kind of research that people will work for. Then the next thing is convnets are everywhere. Is there a message on the chat screen? Okay, so next thing, so this is just a second. The next part is convnets are is that this is being used for, you can just see benign and malignant. Malignant is cancerous, so identifying whether it's a cancerous scan or not. Then it's being used in astrophysics for identifying the position of stars, or sometimes predicting the movement of a particular asteroid, because asteroid, not steroid, asteroid. So asteroid, you know, is like a heavenly object, and so many times we read that it's going to hit the earth, and now we are saved by this much, or a comet has fallen here, there. So predicting this kind of motion is also where AI is being used. then likewise different. So this is landscape identification. This image that you see is known as a captioning problem. Captioning is again a very interesting area of application of AI, and I will give you all examples with reference to healthcare. So I had once come across a very interesting case study where a person basically developed a headgear, you understand, so something that you are tying on your head, and that headgear had a camera, right? And with the help of the headgear, a woman who was visually a mother who was visually impaired was able to read a book to her child, right? So this was a product where this headgear was basically looking at whatever page this lady was flipping. So this lady had a book in hand. She was basically flipping the pages of a book, right? And what happened was that the other like the child is just seeing that mother is flipping the book. Mother is able to listen to whatever mother is able to listen to a captioning algorithm that looks at whatever picture is in the book, and it converts that picture into a textual description. For example, here we have an image, and the system has generated a textual representation of this image and says a white teddy bear sitting in the grass, right? A man in a baseball uniform throwing a ball. So there's a minor error here, but we're just trying to a man riding a wave on the top of a surfboard. So there the a cat sitting on the suitcase on the floor. So of course this example shows that it's possible to work on captioning problem, and it also shows issues related to minor errors or no error kind of a scenario when you are trying to describe an image with the help of a textual representation. But I'm talking about a product development where you have that headgear takes images of the book and converts that into a textual representation that is converted in a audio form, and the mother listens it using the headgear, and she speaks whatever she has listened. So the child has a feeling that my mom is reading this book for me, right? Such a interesting idea. So captioning can be converted into variety of applications, not just one, variety of applications where the picture is being read for you, and then you are doing that, and you can see this will provide lot of visibility. This is computer vision, right? This is why it's known as computer vision. So computer vision essentially means giving vision to your computer. How is your computer getting vision? It is getting by this capability of taking an image and converting that into some kind of representation. This representation could be a textual representation as well, right? So your computer, so that's how you say that my computer is gaining a capability of seeing like humans do. And that is why I said that we are entering an era where artificial intelligence is not expected to be artificial but human like. So if it is human like, obviously the expectation from this kind of application will increase by many fold. This is again an interesting example of AI being used to generate arts, right? And you will see lots of premier research labs, they have started auctioning AI generated portraits or AI generated art, right? So the Montreal lab, Mila lab, right? So Montreal lab of AI in Canada, right? So that I saw on their LinkedIn page that they are auctioning images that are AI generated, right? So that's AI generated art form. This is object detection, everybody knows about it. This picture I like because this tells that AI is also being used for identifying minor changes in moving car by which you are able to identify the model. So this, you see, all these four cars, they look so similar, right? But one is Honda Accord, the other one is CRV, one is Chevrolet, one is Nissan Sentra, right? But they, so that means because the model was trained to identify very low level features to high level features, they are able to distinctly identify the car based on their model. So what are the major architectures of deep neural network? Major architectures are unsupervised pre-trained networks, convolutional neural networks, recurrent neural network, and recursive neural network. This picture basically tells us about different kinds of other variants of these four variants that we have seen. So UPN, which is unsupervised pre-trained network, this has your generative adversarial network, which is a kind of deep neural network for generation of images, autoencoders. They are all unsupervised pre-trained network, right? Then you have recurrent neural network, which is used for sequence to sequence learning. That means extracting features or temporal features from data, right? Then you have convolutional neural network, which is extracting spatial features from data. Then you have recursive neural network, which is again unsupervised RNN and recursive neural network and things like that, right? So these are the four categories, major categories. Unsupervised pre-trained network, we already saw generative adversarial network. Then CNN, these are all different kinds of standard networks. All of them are standard networks, which or they are also termed as pre-trained networks, which are used for development of which are used as convolutional neural network. And convolutional neural networks are basically used to extract spatial features from the data, right? And recurrent neural networks are basically used to extract temporal features from the data, right? So recurrent neural networks is LSTM GRU, and now we have transformer based networks as well. So they are basically used for extracting temporal features from the data. And then we have recursive neural network, which is recursive autoencoder. And some of the use cases where recursive autoencoders are used is image scene decomposition, natural language processing, audio to text transcription. So you may not remember about all these models, but I wanted to show this to you so that you don't see CNN as a de facto standard for deep neural network, right? So CNN is just one of the network. There are so many other network that falls in the category of deep neural network, and we need to know that so that you can map them to different kinds of application development. Okay, so now the next discussion that we are going to have is difference between artificial neural network and convolutional neural network. That in the prior slide we already saw that here you are dependent upon the exact features. For example, identifying apple by saying that look at the size, shape, look at the color, look at this, that, and then going and identifying an apple. And here you are just showing the image of apple to the system, and the system is identifying its own mechanism of extracting the features to distinctly identify an apple and not get confused when it sees a green apple, right? But again, everything will basically depend upon what you are feeding to that system, right? So that aspect is equally important. Now, this graph basically shows analysis of different kinds of deep neural networks. So you see, if you just compare the top one accuracy or of these models, then the recent one, which is Inception V4, is considered to provide a better top one accuracy as compared to LXNet. So LXNet was the first model I told you, 2012 award-winning model, but thereafter lot of convolutional neural network models have developed, like VGG16 or ResNet or Inception or GoogleNet, so many of them, right? And you see that their accuracy is much higher than what LXNet could provide. Okay, so basically when you're using convolutional neural networks, what happens is you give this kind of input to the system, and the system first extracts low level features. So low level features are basically edges or dots. That's all. They are termed as low level features, identifying specific edges and dots. And then what you're doing is you are constructing high level features based on the low level features. So from these edges, we are making arc like structures, and these arcs might be structures which are within the image that you are trying to identify. And so that's why we say we are going from low level features to medium level features to high level features. And high level feature is something which is closer to the original representation of this class, right? So this looks like elephant, right? So these features are, that's why termed as high level representation. So a typical deep neural network will basically have this kind of untrained network, and then this network will be trained to distinctly identify a particular class as it is, and that particular trained model will later go through the inferencing phase, and inferencing will basically prepare your model for deployment in real time circumstances. So if you see the life cycle of a deep neural network, it is training and inferencing. And inferencing is also termed as testing at many places, right? So inferencing basically means testing your data on an image that it has never seen before, right? Structurally, your convolutional neural networks will have a feature extractor, right? And it will have a classifier, right? And feature, so this is your input image, this is set of your feature extractor, and your feature extractor is going to extract features from which are from low level to medium level to high level. And after the extraction of features, you are feeding everything into a fully connected layer or fully convolutional layer, and eventually you are basically getting your output classified as the class which is your class of intention, right? Now the rest discussions, we are going to focus on understanding what is this convolution. We will not be discussing each of the networks, but we'll be discussing about convolutional neural network, because that will set our understanding clear in terms of understanding different other model architectures of deep neural network, right? So a convolutional neural network means networks of this type, they basically have different components, right? And one of the important components of a convolutional neural network is the convolution layer, right? So how does the convolution layer basically behave? Okay, that part we are going to see. So now, in order to understand convolution layer, assuming that we have an image of 32 cross 32 with three channels, these three channel is your three RGB channel, R, G, and B. So it's like you have a slice of 32 cross 32 pixel representing R channel. You have a slice of 32 cross 32 pixel for G channel and for B channel. So you have three channels of 32 cross 32. So you can see the number of pixels that you have. So number of pixels that you have is 32 cross 32 cross 3, right? So that's the and this is your total spatial structure of the input image. And then what you're doing is you are basically taking a filter of let's say size 5 cross 5 cross 3, and you are convolving this filter over the image. Convolving essentially means moving from here to here, from here to here, from here to here over this particular image. So with this image, I have tried to explain what is this convolution and filter basically doing, right? So if I represent it this way, this is my filter, right? Filter which I have put here, and this is your input image. I'm just representing it like this, and this same as that 32 cross 32, but we don't have 32 over here. So convolution essentially means you are taking your filter, which is feature map, which is 1 minus 1. So 3 cross 3 filter we have taken, and you are convolving. Convolving means 5 into 1 plus 2 into minus 1 plus 3 into 1 plus 6 into 0 plus 3 into 1 plus 4 into 0 plus 7 into 1 plus so and so, and then getting summation of this multiplied term. Whatever is one value, that it becomes your R11 of the output feature map from this convolution layer. So output of this convolution will give us R11 as a result of this particular multiplication. And then what you're doing is you are basically shifting this by 1 this way. You are shifting this by 1, okay, and again you are doing this multiplication and addition, and finally you are getting R12, and again you are shifting this by 1. You are doing 3 into 1 plus 76 minus into minus 1. जो भी इस total का sum आएगा वो हम बनाएंगे R13. So I hope you understand that R11 is a result of so many, how many? 9, right? So 9 multiplications and 9 addition giving you R11, and likewise R12, and this will go on, right? So so in the next step this will be like this, then that's it. So here, so we are able to reach till this much. Okay, now what happens is that if you are just stopping over here, so you have convolved this, but what about shifting it this way? You cannot, because your layer has completed here. So in order that we are able to and convolution means what? Extracting features. So in order that in order that we are able to extract in order that we are able to extract the edge level features. Edge matlab, you understand, the features which are at the borders. So in order that we are able to extract the edge level features, it is important that we are adding a zero padding layer over here, right? So when you're adding zero padding layer, you can do this you can consider these two columns also, right? And एक और अगर हम zero लगाएंगे तो you can do this. So if you are adding 2 zero padded layer on the sides, so you will be able to convolve even the edge level features. All right, so this is one understanding that you need to have what is padding. And the other thing is the shifting that I'm doing over here is basically known as striding. And if stride rate is 1, that means you are shifting by 1. If stride rate is 2, that means you are shifting by 2. Here we are shifting by 2, right? So stride rate is 2, we are shifting by 2, right? And whatever we have done horizontally, that's being done vertically as well. So shifting by 2, this is again shifting by 2. Okay, and likewise shifting by 2. So you understand. So if stride rate is 2, what does it mean? And accordingly, the size of your output filter will basically reduce. Okay, so this was important to understand the concept of this is another example where if your input is like 35281 and your feature map is 100110001, then this gives us 25, then again shifting by 1 gives us, so your 5 cross 5 gets reduced to 3 cross 3. This is convolution, right? And what is this? This is a feature that we have extracted from here, right? So that's how you interpret this. So basically, if an input of size 32 cross 32 cross 3 is convolved with a filter of size 5 cross 5 cross 3, your output activation map is going to be 28 cross 28 cross 1. And this can be calculated by the same process which you saw over here. And there is also a mathematical formula to do this, right? And that formula is I don't think if I've kept it here, but that formula, just let me check. Yes, so just a second. Yes, that formula is W minus F plus 2P divided by S plus 1, where W is basically size of your input image. So suppose if your input image was 32 cross 32 cross 3, so this was 32, minus 5 was 5 cross 5 was the filter size, so minus 5 plus 2P. Plus 2p is p is the number of padding layer that we have. So padding layer, let us assume that padding layer is 0. So we can make this 0 divided by, suppose stride rate was 1. So this will become 32 minus 5 divided by 1 and plus 1. right? So what is the number? 32 minus 5 is how much? 20. Um, what will be the value? Just tell me. 32 minus 5, if you have your image as 32 cross 32 and your filter size is 5, what will be the size of the output volume? Why don't you substitute and write on the chat window? So that's 28 cross 28, right? So that's what we had seen in that example. So output filter will be, or output activation map or output feature map will be 28 cross 28 cross 3. So next time you see AlexNet model or you see any other kind of deep neural network model, you will, if you remember this equation, you will be able to find out that how is this size basically changing. If my input is this, convolution is using a filter of size something cross something, then how is the output basically changing accordingly, right? So this will help you to understand that particular process. So you can remember this equation. And likewise for this padding which I told you, there can be different ways by which you can use padding. So zero padding is the most common technique which people are using to basically adjust your dimension as per the output volume that is required. But there can be different options to padding, like padding with a constant value or padding with the edge values, padding with maximum value, mean value, median value, minimum value, and so on and so forth, right? And what value you are using for padding will basically depend upon what kind of application you are talking about, right? So basically now this is just an example of an image classification task which is done using convolution neural network. And you can see that typically we need to work with the training data which is like 10 to 100 million images, and we need to develop a network architecture which is having either 10 to hundreds of layers, train the model for 1 billion parameters, and the learning algorithm will basically need to work on 30 exaflop or 1 to 30 GPU days. So these statistics that you have here basically makes us understand that when you are working on models like this, it is important that you work on larger data sets, because the feature extraction is automatic, right? So the more you expose to the system, better learning the system is eventually going to develop, right? But of course there are complications to that as well, which we will see when we discuss about overfitting. This example that you are seeing is just example of a simple neural network model which is used for digit classification. So you know that we have convolution. Okay, one thing we didn't discuss, which is max pooling. So max pooling means downsampling by half, and you can see that your convolution filter, if your input is size 28 cross 28 cross 1, so one channel, because it's a black and white image. RGB is when you have a colored image, and you are using convolution filter of size 5 cross 5 cross 1, right? Whatever is the number of channels, same number of cross 1 or cross 3 you have to use. And the output of this will be, you can use that formula, W minus F plus 2P divided by S and overall plus 1. So that will give us 24 cross 24 cross 1. And see, N1 may not be 1, right? So and suppose if you are using, let's say, N1 number of feature maps of size 5 cross 5, that means 5 cross 5 is our filter, and let's say we are using N1 such filters. So whatever is the number of filters you are using, those many feature maps you are going to generate. So whatever is the number of N1 feature maps over here, those many number of channels now your output of convolution will basically have, right? And then in the next stage, what you try to do is that you try to reduce the number of features, because now from cross 3 we have come to 31. So slowly what is happening, you can see in a convolution neural network, your size of the features are reducing, but the depth of the feature is increasing, which means that you are able to localize the features and have many features of this type, right? Localizing the features and many features of this type, and likewise for rest of them. Okay, so max pooling is basically going and reducing the features by half, then again convolution, max pooling. Finally, you get your output, which is many features. So in this case, it is N2 and of size 4 cross 4. Then you can see that this dimension is then flattened. Flattened means it is converted into a single dimensional vector, because it needs to be fed into a artificial neural networks. So now this part is like that regular machine learning wala ANN, which you know. So here we are now, so because now we have extracted the features using all this thing, right? So you are now able to feed the features over here, but whatever is the size of input over here, so this is your fully connected network of, let's say, n3 units. Your size is features are basically flattened, they are converted into a single dimensional vector that is being read into your neural network, and finally from this you are able to generate your, let's say, 9 output classes, which is the outcome of your digit classification, right? So that's how you interpret your convolutional neural network. So what pooling does, you understood. Pooling is basically to reduce the size of spatial features, right? And there can be max pooling, average, different kinds of pooling: max pooling, average pooling, mean pooling. Average pooling is used when you want to smoothen the output. Max pooling is used when you just want to focus on the brighter features, and mean pooling is used when you want to just focus on the darker features. So you know that max pooling is most popular. Why? Because we want to focus majorly, in majority of the application, we want to focus on the brighter features as compared to the darker features, right? So that's a important understanding for us. Now the other aspect when you are talking about working with deep learning model is understanding the cycle of training, deployment, and performance analysis, which is tuning your model, right? So training, now you all understand. Deployment is just before deployment you are testing or inferencing the model, and deployment of the model is basically to prepare your model for production, right? So preparing your model for production basically means working towards model optimization, and model optimization is again a different area of discussion, right? So we will not get into that, but we you should just be knowing that preparing your model for production is again something different. It is not just related to training and testing, and that will require working with the production servers like Triton server or NVIDIA TensorRT, right, where you are able to deploy your model in the production environment and test it accordingly, right? So now when you are going through this aspect of iterative model training, preparing your model for development of some application, so these two concepts are important. One is known as your model parameters. So model parameters means anything that you are learning during the training process, and hyperparameter means something with which your model is initialized. So learning during the training process means weights and biases of your neural network, and hyperparameter means your dropout or number of hidden layers, right, or the error function which you're using, or Adam optimizer if you're using. So these are all your hyperparameters. So they are like metadata or meta description of your model, and this is something that you're learning during the training process. And this image that you see is of overfitting. So overfitting is basically loss of model generalization, right? So loss of model generalization essentially means that you are making a very specific model which will work only for a specific scenario. But when we are developing an overall system, then your model should not be very specific, it should be generalized, right? For example, designing a bed that is exactly like this. Now you know the problems of this, right? So if somebody else wants to use your bed, then he has or she has to sleep exactly like this, have this stature. If it's a small child, maybe the child will just fall somewhere here, right? So that means this is not a bed that we ever want for us, right? You never want a bed like this. So why? Because this bed is a generalized structure, and this is not a generalized structure. So overfitting basically means doing this kind of model training which just fits to a particular kind of data, and that is why it is not to be preferred. And how to avoid your models from being overfit? You can use data augmentation, you can use the different kinds of resampling technique like k-fold cross validation, you can do dimensionality reduction so that your model is not training on noisy data, and you can use dropouts, or you can use regularizers like the L1 and L2 regularization. So I am just touching these concepts. Everything we will not be discussing, but I want to give you a breadth-wise knowledge of the scope of deep learning so that you can touch the right points whenever you are working on these concepts, right? The other aspect of model training is feature normalization, where this is basically a process by which you are reducing the size of representation of your features, right? So suppose if your value is between 0 and 100, then converting that into 0 and 1, all the values in the range of 0 to 1, or all the values in the range of -1 to 1. So in deep learning and artificial neural network, there is another concept which is known as activation functions. So activation functions are basically used to add a level of non-linearity to your models, right? And that non-linearity also goes and basically reduces the size of representation by basically converting your weights in one particular range. And like I told you, that all the values will be converted to, let's say, -1 to 1, or 0 to 1, or something like that. Okay, now based on this, we need to summarize our understanding, and for that I would like to ask you these two questions, right? First question, which says that if we need, now see, this is if you know of what is model training, then you know that this is a graph where we are plotting the training loss and what's that accuracy loss, right? Sorry, the loss during the training time and the loss during the validation, that means the testing time, right? So blue color is the loss during the training time, and the orange color is the loss during the validation time. Okay, so suppose if the graph is like this, then sorry, the blue colored is the loss during the training phase, the green color is the loss during the validation phase or testing phase, right? So these two are to be equated, and the orange color which you are seeing is the accuracy of validation, or the testing phase, right? So suppose uh, based on this scenario, you are asked a question that minimize which curve represents a trained network that can successfully classify the new instances. So what will be your answer? You can write on the chat window. For the first question, suppose if you want to focus on successfully classifying the new instances, minimization of which curve represents a trained network, an efficiently trained network. You can write your answer on the chat window. Anyone? Let me see if there are answers. Orange curve, green curve. Okay. So the answer to this question, okay, now minimization of which curve represents a train network that can successfully classify new instances. So, one person said green curve, but majority of you said orange curve. The answer is green, right? So because accuracy will depend upon your loss, and which loss is more important, the loss that you have during the testing phase, right? So irrespective of whatever loss you are getting during the training phase, if the testing phase loss is not minimized, then that will lead to a bad model training. Why it is so is because your testing loss or validation loss is basically testing the model on scenarios which it has never seen before, right? For example, I am teaching some concepts to you, and then in the evening I'm asking the same question, right? So that has a different outcome. But suppose I ask you a different question altogether, which was not directly covered in the session. So that is actual test of the training, that if you have understood, will you be able to answer this question? And this question was not a direct question from the session that was conducted, right? So that's called testing loss. So basically minimization of the green curve is something that will help us to know that your model is able to successfully classify the new instances. Answer should be green curve. Now so always remember that the it is always important to have less testing loss or validation loss for your model training, right? So if you get 90% accuracy of your training loss, sorry, your training loss is, let's say, 80%, and your testing loss is, let's say, 90%, then this is a problem, right? But if the reverse scenario is there, then that means some magic has happened, and in spite of having a bad training loss, your testing loss is good, right? So basically our focus is on minimizing the green curve. Then the next point is, which loss curve would have had a higher value if the model was overfitted? What is your answer on this? Again, you can write on the chat window. Which loss curve would have had a higher value if the model was overfitted? Which loss curve would have had a higher value if the model was overfitted? So if the model was overfitted, overfitting means what? Overfitting is not a good scenario, right? If the model is overfit, then which curve would have had a higher value? The green curve only, no? Right? Because if your model is overfitting, then your test loss will increase, right? So that's actually one of the definition of overfitting. That overfitted model means a model where the testing loss is higher as compared to the training loss, right? So that is called overfitting. So for example, if you teach your students exactly to go for a particular scenario, right? If you are teaching your students very strictly that if somebody is asking you this, you have to say this. If somebody is asking you this, you have to say this. And tomorrow in the exam, altogether different question has come which the student was not prepared for, so you will have a higher failure rate if the student was taught based on very strict instruction कि इतना ही करना है आपको, इससे ज़्यादा नहीं करना है, suppose. So then it's a bad overall the entire process is bad, right? So you can relate it with that scenario. Which loss, so that means your model has lost its generalization, or the model is overfit, right? Model is overfit, or model is known to lose its generalization if the testing accuracy or testing loss, accuracy and loss, they are reciprocals of each other. So if the testing loss is higher as compared to the training loss, right? Or the accuracy, testing accuracy is lesser as compared to the training accuracy. That's how you can compare, right? So the answer to the second question is also green color only. Now third, so these are actually conceptual questions I'm asking, so that you will remember this when you are actually training your model. The next question that I want you to answer, after this we will take a break and then we will join back. Okay. Next question that I want you to answer is, what does the network learn from validation data set? Validation is when you are testing your model, right? So your testing here, we are calling that as validation. So what does your model learn during the validation phase or from the validation data set? What is your answer? It learns whether model is fitted, overfitted. No, my question is, what does the network learn from the validation data set? The answer to this question is that the model does not learn anything from the validation data set. Validation, you in your examination paper, do you expect students to learn anything? No. You are only testing how much they know, that's all. Right? You are not teaching during the semester end examination, or you are not expecting them, you are not in fact supposed to design questions by which you are teaching them anything new. They are just being tested on things that was taught to them before, right? So that means, what does the network learn from the validation data set? The model does not learn anything from the validation data set. It is just a test of their learning which they have done till now, right? And always remember that whatever learning word we are using here, learning essentially means weight updation, right? Learning means weight updation in the weights of your model. That is what is known as the differential change in the weights, is what is known as learning. So when you are saying that in the validation phase the model is not learning anything, it means there is no change in the weights during the validation phase. Okay. So you have to basically have your concepts clear on this concept as well, right? Minimization of which curve represents, so here it's green curve, which loss curve would have had a higher value if the model was overfitted. So it's again the testing curve, which is the validation loss. And what does the model learn from the validation data set? Answer is, model does not learn anything during the validation data set, right? So these are some concepts which you need to know. There is another concept in model evaluation which is known as number of epochs, right? So number of okay, let us discuss this after the break, right? So what is the time for your break? It's how
Ma'am,
much? 15
actually,
minutes?
there is a
Half an hour?
half an hour break, like from 11:30 to 12.
Okay. So do you
So,
want half an hour break or 15 minutes is okay? You decide.
so 15 minutes is okay, ma'am?
15, for me it's fine. We'll just take a cup
Okay.
of tea and come back. because there are a lot of things to be covered, right? So let's
Okay.
join back at 12 o'clock.
Okay, thank you so much, ma'am, for such a brief discussion.
Yeah,
So, would
thank
love to hear you in the next session.
Yeah, sure. I'll
Thank
continue
you.
with these discussions and then we'll have case studies on developing decision support system for Parkinson's disease, right? So that we
Okay.
will discuss in detail in the next session.
Okay, thank you, ma'am. So, I
Yeah.
humbly request all the participants to kindly join by 12 p.m.